Textbook by Martin Gay, and let's start with page 253. Page 253 of the Martin Gay book. And the first topic I want to talk about is reducing fractions. Let's start with a nice simple problem like number 14. Number 14 on page 253 says 3y is divided by 6y squared minus 30y. And my first question is, can you reduce this fraction? First off, can you divide the 3 into the 6 or the 3 into the 30, or can you divide out a y perhaps? Well, before you reduce any fraction, there's one principle you have to remember. The only time you reduce a fraction is when you can divide out one factor of the numerator with another factor of the denominator. In other words, what's the key word in that sentence I just said? Factor, right? All right. Especially in view of the fact that last assignment that we had was on factoring, okay? In other words, a prerequisite for reducing fractions, a prerequisite for even seeing this topic of fractions presented is that we must assume you know how to do factoring, because factoring is the first step. What can you do? Can you factor the denominator perhaps? And let's keep the numerator just what it is, 3y divided by. Now factor the denominator. Is there a common factor there? Y and 6. Okay? And 3, 6, and y. You're all right. Those are all common factors, aren't they? So what do we have to do now? Get the largest one. What would be the largest common factor?
6y.
6 and y. So if you take out the 6y, now what would be left in the first position? Y, and then minus, and then we took out a 6 from the 30, what would that leave? 5, and we took out the y, so that's it, just y minus 5, right? Now can you see that this 3 is times y, and the denominator is 6 times y times, these are all multiplications in here, aren't they? This is times, times, times. So you can divide out any factor of the entire numerator with any factor of the entire denominator. So we could divide out the 6 with the 3. We can divide 3 into the numerator, goes 1 time. You can divide 3 into the denominator, goes what, 2 times? Y divides into y. And now the final answer, everything divided out of the numerator, so what's left in the numerator if everything divides out? There's always a 1 left there. And then what's left in the denominator? A 2 and times the y minus 5 factor. Right? So that's how we reduce a fraction. Is there any question on that? All right? Now, I deliberately started with number 14, and I skipped problems 1 through 8. Because problems 1 through 8 are a little bit confusing. They're not difficult, but they're confusing as to what the author really wants you to do. So let's go back to number 6. And I'd like to do number 6. The problem says 3 divided by 5 plus x. But what I really need to do is read the instructions to the problem here. Here's what it says. Find the values of x, if any, for which the rational expression is undefined. Does that tell you what they want you to do? The key word there is rational expression. What do they mean by a rational expression? What is a rational expression? A fraction, in other words. A rational expression is a mathematician's way of saying a fraction. And we want to know, for what values of x would this fraction be undefined? Now, what would cause something, a fraction, to be undefined? There's one thing that you're not allowed to do in math. Denominators cannot be 0. In fact, in a previous section, we talked about the domain, remember? When we were finding domain, we were actually doing problems like this. We were saying, what values of x are allowed? When we found the domain, we were saying, what values of x are allowed? And now this book is saying, find the values of x that are not allowed. You see, they've turned the question around. They're asking the question in a negative way from what we were asking it before. When I asked you to find the domain before, I said, what values of x are allowed? And now what it says is what values of x are not allowed. So what's the one thing that's not allowed in this problem? 5 plus x, what?
0.
Cannot equal 0. Okay? Cannot equal 0. So therefore, what is the forbidden value of x? X cannot equal negative 5. Do you see that? So the question says, find the values of x for which the fraction is undefined. What values of x would make this fraction undefined? X equal negative 5. All right? Try number 8. Problem number 8. The problem says 7 divided by x squared minus 25. All right? Now, what values of x would be not allowed for this problem? In other words, the denominator. What's the requirement for this denominator? X squared minus 25 cannot equal 0. Okay? So find the values of x that are forbidden, in other words. What values of x would cause this to be undefined? Can you tell me? X cannot equal 5 or negative 5. All right? X cannot equal plus or minus 5. Okay? Now, let me go back and see about the wording of this. It says, the way the problem was worded, it says, find the values of x for which this is not allowed. The values of x would be x equals to 5. You see? In other words, if I said what values of x are allowed, I would say x cannot equal negative 5. The way this author is asking the question, you would say what values of x cause this to be undefined? The answer the author gives is x equals 5. You see that? If you wrote x equals 5, x not equals 5, I think either way we would understand what you mean. But the question says what values of x would cause this to be undefined. So the values of x that cause it to be undefined would be x equal 5. The values of x that cause this to be undefined would be x equals plus or minus 5. Okay? Now go back to the hardest one of all, number 2. Problem number 2. And then we'll get off of this and get on to something more interesting. Oops. Number 2. The problem says 4 minus 3x divided by 2. Okay? What values of x would cause this expression to be undefined? Can you think of any way to make that denominator 0? No way. There's no way you can make this undefined, is there? So the question says, find the values of x, if any, for which this is undefined. What are the values of x? There are no values of x that will make this undefined, see? So the answer is none. Is that confusing? Maybe it's the way we're asking the question that's confusing, but it's an important concept, and it shouldn't be that difficult a one. All right, take a look at another. Let's get back to number 16 on page 254. Page 254, number 16. Page 254 now. And the problem says, number 16, it says x minus 5 divided by 5 minus x. What do you notice about x minus 5 compared to 5 minus x? They're not the same, are they? What if I gave you something like let's say, 6 minus 3, and asked you to compare it to 3 minus 6? What happens if I reverse the order of subtraction? Is it the same? It's not the same, is it? This one comes out 3, this one comes out negative 3. You see that? What happens when you reverse the order of a subtraction? It's the negative of it, isn't it? So in other words, the denominator here of 5 minus x is actually the negative of the numerator. And what happens when you divide a number by its negative? You automatically get what answer? Negative 1. See? If you divide 3 by negative 3, what do you get? Negative 1. If you divide 10 by negative 10, what do you get? Negative 1. When you divide any number by its negative, you get negative 1. So what happens when you divide a number by its negative? It just goes negative 1 times, and the final answer is negative 1. Is that simple? Well, there's a more complicated way to do it if you'd like. If you want to do it by a more complicated way, you could say x minus 5 divided by 5 minus x. take that denominator and factor out a negative 1. Just because I don't like the looks of it, let's just factor out the negative 1 from the denominator. Then what would you have? X minus 5 for the numerator, and then let's take out a negative 1. What would you have left in the parentheses? Negative 5 plus x, right? Negative 5 plus x, or x negative 5, right? So if you factor out a negative 1 from that denominator, then can you see that this x minus 5 divides out with this x minus 5, and what's left in the numerator? 1. So your final answer is 1 divided by negative 1, and 1 divided by negative 1 would be negative 1. Is that right? Negative 1 for the answer? Okay? Which way do you like it? Whichever way you can understand, it'll be fine. You can do it that way. All right? So that's two ways to do that problem. Take a look at next I'd like to look at number 19. Number 19 says 7 minus x divided by x squared minus 14x plus 49. Can you factor the denominator? Yes. Right, let's keep the numerator just like it is, 7 minus x. What is the denominator? You want to do like this. Factor it into a product of binomials, x, xx, negative 7, negative 7, right? What do you notice about this 7 minus x and this x minus 7? This is the opposite of that, isn't it? When you divide a number by its negative, what would it be? Negative 1, right? So I get an answer of negative 1 divided by x minus 7. Now to me that's a good enough answer, but one of the traditions in math is to write the answer with as few negative signs as possible. And there's another way you could write this answer that would give you less negative signs, and that is to multiply the numerator and denominator both by negative 1. If you do this, you'll get a different form of the answer that might be preferred by some people, but I'm not sure. The answer to the numerator would be what? 1. The denominator would be
7 minus x.
7, positive 7 and negative x, or negative x plus 7. That'd be 7 minus x. You see, that's a different answer, 1 over 7 minus x. That's the answer given in the back of the book. But if you gave this answer the way I originally left it, that would be negative 1 over x minus 7. That's good enough. That's good enough. This is only slightly better. See, this has two negative signs. This only has one negative sign. And you're splitting hairs if you want to say this is the right answer and this is the wrong answer. I don't think that's a wrong answer at all. Okay, any questions on that? Okay. All right, now let's go to number 26. Again, what we're doing in this section, we are reducing fractions. That's all this first section is. Section 6.1 is reducing fractions. Number 26. Number 26, the problem says 2x cubed minus 5x squared plus 2x minus 5 divided by 3x squared plus 3. Okay? Okay? Now, what's the first step in order to reduce a fraction? It has to be factored, doesn't it? If it's not factored, you can't reduce it. In other words, don't try to divide something out up here. Don't try to divide out x squared with x squared, because that's blasphemous. That's not allowed. You have to have it factored first. Now, what thought about factoring comes to mind when you look at that numerator? Grouping the first two and the last two. There was a way you can guarantee that that's first two and last two factoring. What was that method we had? Take the ratio of 2 divided by negative 5, and then take the ratio of 2 compared to negative 5. And if this coefficient, the first divided by the second, equals the third divided by the fourth, if that ratio comes out the same, then you know grouping is going to work first two and last two. So let's group the first two and take out what? X squared. And what's left? 2x minus 5, right? And then plus. Now, the last two doesn't look like there's anything to factor out. Well, we got to factor something out. If you can't think of anything else to factor out, then plus 1. How about a 1? What's the important thing? If grouping is going to take place, you have to end up with the same grouping here as you do here. And what if you take out a 1? Then what would be left for the second grouping? After you take out a 1, what would be left? 2x minus 5. Isn't that nice? Because this is going to match up with that, right? Okay? Now, in the meantime, what about the denominator? Can you factor the denominator? Let's take out a 3 from this. Let's do this part in green, all right? Take out the 3, and what would be left? X squared plus 1. Okay? Any questions so far? Can we reduce it at this point? Have we factored it? Now see, I haven't finished the factoring. Now a lot of people will take this step. They do this part, right? And then they'll try to divide something out. You know, like x squared plus 1. No. You can't divide anything out until you get it factored. And it's not factored. This numerator is not factored. You see, that part's factored and this part's factored. But overall, it's this plus this. And when it's this plus this or this minus that, then it's not factored. So what do you have to do? Take out the common factor, which is the 2x minus 5. We're going to take that common factor out and put it down right there. 2x minus 5. Put down the common factor. Now, what's going to be left when you take out the common factor? X squared plus 1. And now, the denominator is just what it was already. 3. We already had that factored. X squared plus 1, right? Now, do you see any factors that divide out? Divide out the x squared plus 1 and the x squared plus 1, right? And now, the final answer, what is it? 2x minus 5 divided by 3. Okay? Any questions on that? Okay. I think that'll take care of that section. Now, the way this textbook is organized, the first 32 problems, the first 32 problems are set up in a way that it refers you to a specific example. And it tells you which example to look at. Then after you go through the first run through the exercises, then they give you a general set of exercises with no example to refer to. And this is what happens beginning with number 33 through 74. You just have general exercises to solve by whatever method you can think of. So be sure to get enough practice on these. I am deliberately skipping some problems here. I'm skipping number 27 through 32, and I'm skipping number 75 through 86. I deliberately omit those. I consider those problems confusing, and it's harder to understand what the author wants you to do than it is to actually do it if you understood what you were supposed to be doing. So I have a different approach to teaching, and I don't use that. I'll have you able to do what they want you to do there without doing those exercises. So you can omit those problems without any loss of explanation on my part. Now, the next section, section 6.2, after we learn to reduce fractions in section 6.1, then we have to do operations on fractions. So guess what we have to do now? Operations, what does that mean? Multiplying and dividing, right? And then section 3 will be adding and subtracting. I think you're going to find that multiplying and dividing are almost the same as what we were doing here, so I'm going to cut the explanation short on this section. I'm just going to do one exercise to give you a sample on page 260, and then we'll get on to the ones I think are going to give you trouble, and that's adding and subtracting fractions. Now, when you multiply and divide fractions, there is one step that is very important. Just like on the last section, and you want to guess what that is? Factoring. If you ever don't know the answer to one of my questions, you can just say factoring and you're probably right, because that seems to be the prerequisite for everything we do here. Take a look at number 56 on page 260. And let me use this as a sample problem. 2a squared minus 2b squared divided by